Hello, everyone, and thanks for joining this Tips for Cutting Costs on Injection Molding, presented by Quick Parts. Today, our speaker that will be talking will be Ashish. He is the manufacturing manager here at Quick Parts. He's got extensive knowledge in many different processes and manufacturing methods. Ideally, he is very knowledgeable in injection molding particularly. So that said, we'll get started here. I'll hand it over to Ashish to begin.
Thanks, Matt. Yeah, today we are going to discuss initial part design considerations, reduce cost, some suggestions for material options, and discuss considerations for saving costs on tool modification. So first thing and most important thing is optimize your part design, right? It is called design for manufacturability, right? So design your part to facilitate injection molding process and tooling. Um, Recommended wall thickness. So for every material we use, there is a recommended wall thickness, right? ABS, PC, nylon, EPS, PBT, all materials have their own recommended wall thickness range. So try to keep your wall thickness within that range. If you use like a thin, it is thinner than recommended, then you may have short part will not fill, issues like shorts, flow lines, other defects will occur, and maybe some areas will stay weak. So that is because of thinness, and if it is too thick, then it might have sink marks, blowholes, warp, and plus thick part will have more weight. So more weight is not desirable either. So, typically keep it thin, right? So that will save you on weight, you require less material, but at the same time, the mold should be able to fill and you should get good quality parts. So, use optimize, use optimum wall, right? And it depends on the size of the part. So if part is smaller, you can go thinner or flow length, right? So part is big, then uh, you need a little bit more thickness, right? Also, what is important is rib to wall thickness ratio, like ribs creates cross sections. That cross sections is thicker than the nominal wall. So just make sure your rib thickness is about 0.6 times the nominal wall. And just make sure you always follow the standard when you have ribs, right? Otherwise, there will be sink mark. Try to reduce undercuts, right? So if you have some features that causes undercuts, you may eliminate undercuts maybe by adding some shutoffs if possible, or if you have to have undercuts, then try to reduce the number of direction, right? So you can capture many undercuts in one direction instead of having like 8 or 10 different undercuts and 8 or 10 different directions. That will cause like so many side actions. That's not desirable. It will add cost, it will add money, and it might increase the chances of quality defects. Reduce undercuts. Add an appropriate amount of draft. So draft is needed to facilitate ejection, part ejection, right? So ideally 1 degree draft at least is required. Well, of course, we can work with little bit smaller draft, half a degree, depending on the material and surface area, right? But 1 degree draft is desired, so that there is no issue on part ejection, there is no drag marks, part don't stick. For textured areas, refer recommended draft for a particular texture, because deeper is your texture, higher will be the draft to make sure the part comes out right. So optimize part design. So I would say avoid over engineering is just part of, again, part of part design, right? So when you design a part, you also add tolerances, specifications, create a 2D drawing, right? So on that 2D drawing, just make sure you don't specify like too much like tight tolerances, and choose finishes that is unnecessarily expensive, right? For example, you are choosing A3 finish instead of C3 finish for an area that is totally non-cosmetic, not visible to customer. Uh, Try to choose standard. If you have to have like texture, choose standard texture instead of some custom VDI or multi texture that requires more time and money, right? So I guess avoid unnecessary tight tolerances and unnecessarily cosmetic specifications. So identify the volume of parts you need, right? So it typically depends on or at what stage of product life cycle you are. So at an initial stage where you are just prototyping, so just make sure you make a prototype tool, right? Aluminum tool that has just hand load inserts, and we can make in quick parts, like in maybe in 5-10 days we can make a tool that will give you part in correct material, that is production material, and good looking part very quickly. Only thing is that's just tool life is lower, so you can make 2500 parts off of those tools typically, but that is very cost effective and fast. So you can quickly, get parts to the market, test your function, get to the market. That actually accelerate your, product development. Of course, when it is a little bit later, if when you need like a higher volumes, the tool is made accordingly, right? So you have maybe have multi-cavity tool, hardened inserts, and so that you can make large volume of parts off of that tool, and it's more cost effective, right? So just make sure you identify your need off of, you know, for that particular tool construction. So prototype or production, just identify that and make your tool accordingly. Again, cosmetic surfaces, I think we have discussed that earlier, but use standard surface finishes. That helps. Um, so it keeps your cost down. And again, if you choose very high cosmetics, then maybe the chances of rejection are more, right? In the when it is inspected, oh, there is some mark somewhere that your quality will reject. That has no influence at all. At the customer is not even seeing it or nothing. It's just part is getting rejected because it is specified that way. So make sure you use, standard finishes and where necessary. Secondary operations, right? So secondary operations are the operations done after the part comes off of the mold, right? So it could be like CAD printing, uh, or inserting, right? Heat staking in. So you use heat staking press fit insert for adding, added inserts, right? Or anything that is done after post-molding. But everything you do post-molding adds cost. And any additional operation always adds, there's more chance of rejection or quality issues. So, of course, so one example is like if typically all part comes out with gate wastage, right? If you can keep that gate wastage, if you don't have to, trim it, then it saves cost. But if you start to, trim it, it is what it is. Pitch take insert, pressing insert again. Try to, use overmolding insert if possible, so that you can just have that insert come out with the part. As I said, additional operation means more time and chances of quality issues. Next. Material selection, right? So use easily available material, you know, um, some materials like don't choose like very exotic materials unless it is required for the function, right? So engineering plastics like PPS or PEEK or materials are very expensive. They are they are required to be used in particular cases where you require very high strength or depending on the application, right? You might need to use it. But uh, use standard materials that are easily available. Like for example, enclosures, right? Typically they are made of PCABS or ABS, right? So use those materials. They're typically used for that particular application, easily available, cheaper, uh, easier to process also, right? So choose material that are easily available. You may take help of a material supplier who can guide you based on your function so that you choose the right material for your function and that is available immediately instead of waiting for 2 or 3 or 4 or 5 months at a very high cost, right? So make sure you use appropriate material. Stick to a standard colors instead of custom colors, right? Custom colors means either you need to use pre-colored material that again takes longer time and expensive, or you have to mix and match at the press. That again, brings some inconsistency, right? So standard color, standard material. That's so sometimes you need to have certain features still safe. Uh, those features are required to be adjusted depending on the mating part. There's some mating part that it is assembled with, or just require tight tolerance because of the function, right? But identify those features upfront on your 2D drawing so that the tool maker can keep some steel there, keep some stock that can be removed uh, after the tool trial is done, samples are sent, like you assemble the samples and then figure out, okay, how much adjustment is needed so that you can do that adjustment quickly without having to weld steel that is difficult. There's more time, more money, and doesn't look good. Sometimes you just need to change the insert. So that's expensive. So, identify those areas, those features upfront so that it can be kept still safe and dialed in at quickly, uh, you know, after the tool trial is done and samples are made. Next.
I think that about wraps up our presentation here, Ashish. So thanks again. That was very informative and definitely appreciated it myself. So before we end here, give a little bit of information about Quick Parts. Again, this is put on by Quick Parts. So we've been around for over 23 years. We made over 100 million parts. Our operators and engineers have very little turnover here. They're here for a long time. They have a lot of experience. We have unrivaled flexibility of projects with complex projects. very responsive customer service, and we're always evolving our technology to meet your needs and our customers' needs. And just one final thank you. And if you do have any questions, you want to reach out to Ashish about this presentation, any questions about that, or any projects you have coming up, feel free to reach out to us at sales@quickparts.com. That's going to be all again. Thanks again for joining us. Thanks. Bye.
Thank you.